This week we're learning about the water cycle. The title of section 1.1 in your book is called Water Continually Cycles. Before we talk about the water cycle, let's review the properties of water. We know that all matter exists in one of basically three states. Let's review those states of matter now.
Matter, the stuff that everything's made of, is made up of many tiny particles. The behavior of these particles is what makes a substance a solid, a liquid, or a gas. In a solid, the particles are packed closely together in a rigid structure, vibrating about fixed points, but unable to move around. In a liquid, the particles can move around each other, so the liquid has no fixed shape, but they're still very close together. But in a gas, the particles are spread far apart, moving around rapidly and randomly to fill the entire space.
Everything around us can exist in the three states of matter: solid, liquid, and gas.
Put that under your...
At normal Earth temperatures, water can exist in all three states. That's unique to Earth. Normally, other places in the universe, either the atmosphere is too warm or too cold all the time in order for water to exist in all three states, solid, liquid, and gas. Higher temperatures turn water into a vapor or a gas. Lower temperatures on Earth turn water into an ice or solid. And normal temperatures, the temperatures that we experience on a regular yearly basis, keep water a liquid. Water vapor in the atmosphere forms a kind of global blanket which helps keep the Earth warm. And heat radiated from the surface of the Earth is absorbed and held by that vapor. So as the sun's rays come through the atmosphere, hit the surface of the Earth, which is either water or land, and bounce back off of that surface, the water vapor that's down close to the surface absorbs that heat, keeps it there, which acts like a blanket and keeps everything at the temperature at which it will thrive. Another property of water is that it is less dense as a solid than it is as a liquid. Look at this image here of an iceberg. You can see that this iceberg is surrounded by liquid water, but it's not sinking to the bottom of the ocean. Instead, it's floating. Since ice is less dense than liquid water, it means ice floats. Frozen water forms a crystal-like lattice, which means kind of a crisscross pattern, where molecules are set at fixed distances. So, knowing that, which of these two pictures is showing ice and which one is showing water? Well, since ice is less dense, that means ice is going to be over here on the right. You can see that the pattern, it has many more open spaces. And in the water molecules, the molecules are packed tighter together and there are fewer open spaces. Another property of water is called hydrogen bonding. A water molecule, which is made of H2O, meaning two hydrogens and one oxygen, has this pattern where it allows the oxygen and the hydrogens to bond together. Hydrogen bonds exist between water molecules. The larger red circle is the oxygen and the smaller yellow circles here are the hydrogen. You can see the hydrogens have a slight positive charge and the oxygens have a slight negative charge. So those two things are attracted to each other, kind of like a magnet. One hydrogen bond is weak, but many hydrogen bonds together make a pretty strong surface. Other properties relating to hydrogen bonding are cohesion and adhesion. Cohesion is the attraction of particles of the same substance, which is why water is attracted to itself. This cohesion results in something called surface tension, which is a measure of the strength of water's surface. It kind of produces a surface film that allows insects and other things to walk on the surface of the water. But as you read in your previous assignment, it's not the reason that a boat floats. Here are some other pictures that illustrate cohesions. Cohesion helps insects walk across water. The other property related to hydrogen bonding is adhesion. Adhesion is the attraction between two different substances. So water will make hydrogen bonds with other surfaces such as glass, soil, plant tissues, and cotton. Capillary action means water molecules tow each other along when in a thin glass tube, or when in something thin like a plant vein. An example of adhesion would be the transpiration process, which allows plants and trees to remove water from the soil like a paper towel soaking up water. Here's an image of cohesion. Here's an image of adhesion, which causes capillary action. It gives water the ability to kind of climb up structures. Hydrogen bonding also causes water to form droplets. This would be cohesion. And adhesion, adhere to or stick to this blade of grass. Now let's move into the water cycle. Water never leaves the earth. It's constantly being cycled through the atmosphere, the oceans, and on land. This process is known as the water cycle, and it's driven by energy from the sun. The water cycle is crucial to the existence of life on our planet, meaning without the water cycle, we would no longer be living on this planet. Here's the big structure of the water cycle. Notice the arrows essentially form a circle. Cycle means to continually go in a pattern. We're going to learn about each step in this process. First, let's talk about evaporation. Evaporation is when the sun heats up liquid water and changes it to a gas. We have evaporation from Earth's oceans, lakes, rivers, and even moist soil, as well as any other body of water. A puddle would experience evaporation. If you leave a glass of water or a glass of liquid out in the sun, that would experience evaporation. And as water becomes less dense, turns from a liquid into a gas, it rises up into the atmosphere. Next, let's focus on transpiration. The process of evaporation from plants is called transpiration. It's kind of like plants sweating. Now let's focus on condensation. Once the water gets into the atmosphere, what happens then? Water vapor or gas in the atmosphere starts to cool because temperatures in the atmosphere are cooler than they are on the surface of the planet many times, and then becomes a liquid again. So you have liquid water on the surface of the Earth turning into a gas, and then once the temperatures in the atmosphere are cool enough, that liquid water gaseous water turns back into a liquid. When a large amount of water vapor condenses, it results in clouds. Take a look at how this happens.
Hey, I'm in here. I'm in this giant freezer. Now, let's see what happens when I come outside where you are. See, the surface of my bubble helmet of science turns cloudy. That's because water vapor, which was floating around in the air, sticks to the cold surface in little liquid water droplets. Now, this process, this effect, this thing that happens is called condensation. It's the same thing that happens to people who wear glasses when they come in after being outside on a cold day. It's where clouds come from. Where'd you guys go? Oh, funny. Oh, very funny. Anyway, condensation is sort of the opposite of evaporation. Instead of liquid water gaining energy and becoming a vapor, water vapor loses energy, becomes a liquid. Little tiny droplets that stick to cold surfaces. That's a very important thing about condensation. Water vapor needs a place to stick in order for condensation to happen.
Look at the glass next time you drink your milk. Does it seem to sweat? Well, the glass isn't really sweating, of course, but it is wet. It's just the water vapor in the nearby air being condensed.
When clouds form, water vapor turns into tiny liquid water drops. But in order for that to happen, the water has to have some place to stick. It has to have something to stick to. So take a look at this. This is our big glass jug cloud apparatus of science. And we're going to make a cloud in here. First, we'll add a little water. This will be the water that will form our cloud. Just swirling it around a little. Now, using this pump, we'll pressurize the big glass jug. Then when I pull this rubber stopper off, the air in the jug will expand. And that's when a cloud should form. 3, 2, 1. See, nothing happened. That's because the water vapor didn't have anything to stick to. So what we're going to do is add some dust. Just a tiny amount of dust. And to make the dust, we'll use the smoke from these two matches. That's all the dust we need to form a cloud. Now watch. We'll pressurize it again. When we pull it off, the air in the jug expands. And when it expands, it cools off. The same thing happens to air masses when they get blown around by the wind and pushed up high into the sky. 3, 2, 1. See? It's a cloud. It's the water cycle. It's science.
So, back to condensation. As you can see, when a large amount of water vapor condenses, it results in clouds. Now let's move on to precipitation. Precipitation is when the water in those clouds gets too heavy, that water falls back to the earth. It can be in the form of rain, sleet, snow, ice. Any kind of water falling from the sky is called precipitation. Next, let's move on to runoff. Runoff is when rain falls on the land. Some of that water is absorbed into the ground, forming pockets of water. That's called groundwater. Groundwater eventually returns to the ocean. Other precipitation runs directly into streams or rivers. That's called runoff. Those go directly into the ocean. So, one last image of the water cycle. You can see as evaporation happens, it turns into condensation, which forms clouds. Then from those clouds you see rain. The sun either melts the snow or aids in the process of the water cycle. Without the energy from the sun, the water cycle would not continue. If you have any questions, make sure you send me a message.